Okay. Ayan. So, good afternoon. So, we will discuss timber columns. Okay. So, for today, so yung columns natin is maybe short or a long column, 'di ba? So for a long column, ang the limit state will be backlink. So mas madaling baluktutin ang long column compared to a short column whereas yung ating short column is under crashing or yielding limit state. Okay? So ang ginagawa pagdating sa pagde-design ng column is kukuha ng trial size. Okay, kukuha ng trial size or magi-establish muna siya ng size. Then with a known size or yung trial size, then i-compare niya kung yung actual stress ba is pasado. So kapag hindi, mag-a-adjust siya ng konti. So parang ang nangyayari, the same na trial and error lang din. Okay, so based on this comparison, the member size will be accepted or rejected. Okay, so under sa timber column, since the timber columns is considering lang yung working stress or tinatawag din na allowable stress design. Okay, so ano lang siya, parang service loads. Okay, service loads. So by strength of materials, you all know that the compressive stress is equals to force over area or P over A lang. Okay? So whereas yung compressive stress or yung actual compressive stress shall be less than or equal to the allowable compressive stress. Okay, yung FC prime, adjusted compressive design strength. Okay, so by formula, FC is equals to P over A shall be less than or equal to FC prime. Okay, whereas your FC prime is the adjusted compressive design strength parallel to the grain. A is the cross-sectional cross-section of your column. P is the actual compressive force, and FC is the actual demand compressive stress parallel to the grain. So take note, mapapansin nyo, lahat yan parallel to the grain. Parallel to the grain, parallel to the grain. So bakit parallel to the grain? Ang sabi kasi sa code is the orientation of our timber column shall be parallel to the grain. Yung load dapat is parallel to the grain. So, di ba ganito? Pwede nating ilagay yung column natin, timber column natin na ito yung grain, this one. Pwede ring ilagay natin yung column natin na pag ganito yung grains. Yan. Okay, so pwede yan. So, which is better? Compare this one, yung parallel to the grain, and this one is perpendicular to the grain. So, ito yung applied load. Okay, ito yung applied load. So, parallel siya dito sa grain. So, this is parallel. And this one is perpendicular. Okay. So, which one is better? Parallel to the grain or perpendicular to the grain? So, going back to the allowable stress table, yung NSCP table. Okay, balik tayo dito. Tingnan natin. So, let's just compare lang. Ayan. Nakikita ba? This one, yung mga zoom in ko pa. Ayan. Kita yung mga values?
Yes, sir.
Yes, sir.
Okay. So, kung mapapansin nyo, class, meron tayong dalawang strength for compression. Compression parallel to the grain and compression perpendicular to the grain. Okay, syempre kung ikaw ang designer, you will go to yung ma-maximize mo yung capacity ng timber natin. So kung i-compare natin, lahat always na mas malaki yung allowable stress when parallel to the grain versus perpendicular to the grain. So tingnan nyo na lahat. So 14.5, 5.91, 15.4, okay, 15.8, lahat yan. So ibig sabihin, mas malakas yung column or yung timber column kapag yung arrangement or yung orientation ng column mo is parallel to the grain versus when the orientation of your column is perpendicular to the grain. So mas mama-maximize mo yung capacity ng column mo or ng timber column mo pag ganito yung arrangement. Kapag ganito yung arrangement, parallel to the grain. So therefore, the NSCP or the code provisions recommended to use or to orient your column or your timber column in this manner or least parallel to the grain. Okay? So, balik lang natin. Kung naaalala niyo yung dun sa beams, is ganito. Ang recommendation din is ganito. Nandito yung grains. Yan. Sa column, ang recommendation is nakaganto yung grains. Okay? So, yan. So, that is a timber column na orientation. So, the working formula nyo is the actual or the demand compressive stress is equals to force over area shall be less than or equal to the adjusted compressive design strength. Okay? So, always parallel to the grain. Okay? So, what are the buckling factors? Di ba? Meron tayong iba't ibang buckling factors when we are discussing the theory of buckling dun sa steel design natin. Di ba? We have different buckling factors. Okay, yung ano ba yung mga buckling factors? I-recall ko lang. Di ba yung buckling factors is, let's say, ito yung column mo, then meron kang support type dito and dito. Let's say pin-pin. Okay, so kapag nag-apply ka ng load dyan, ang mangyayari sa buckling ng column mo when your support, where your column is pin-pin, ang mangyayari is ganito. Lahat ng cross ng length, lahat ng total length magbabakel. Okay? Lahat ng total length magbabakel. So, ibig sabihin, the effective length is this one. So, the effective length, LE is equals to L. Or K, your total length is this one. Your total effective length is equals to the length of your column. Okay? So, ang sinusukat na distance dyan is yung point of contraflexure or yung point kung saan nagkurba yung curve. Saan simulang nagkurba yung curve. So, ito yung kapag pin-pin. Okay? So, ito siya yung iba't ibang arrangement. So, kapag ang itsura is fix sa ilalim, fix din yung sa taas, okay? Ang backling niyan is dapat hindi ganito yung drawing. So, ang backling niyan ganito, class. Kapag fix yung ilalim, okay, fix yung ilalim, fix din yung taas, ang mangyayaring kurba niyan is pag ganito. Yan. Okay, medyo straight dito, ganyan, ayan. Okay. So ito yung point kung saan yung start yung contraflexure mo. This one is 0.5 LE or L. Yun yung LE mo, 0.5 L. However, this is theoretical. So ibig sabihin, theoretical base lang to. Hindi na consider yung mga factor pagdating sa site. Okay, so ang ginamit is KE is equals to 0.65. So ito yung may adjusted factor. Okay, so ito yung gagamitin natin for timber beams. Okay, this one is theoretical. Okay, theoretical, and this one is actual fixity factor. Whereas yung K natin, ang tawag dyan is fixity factor. Okay? So, yan yung ating effective length. So, iba-iba yan. Kapag this one is fix 0.65 yung actual K. This one naman is fix pin. Ang actual niyan is 0.8 whereas your theoretical is 0.7. Okay, try to check your theory of buckling module, I think, hindi ko maalala, module 12 yata yun or module 12 ata. Okay, so this one naman is fix free. Okay, fix. Okay, rotation fixed, then translation free. This one is K is equals to 1.2. Okay, this one is pin yung baba, pin yung taas. That is K is equals to 1.0. Fix free, that is K is equals to 2.1. And fix rotation translation, pin, then rotation fixed translation free, that is your effective fixity factor KE is equals to 2.4. Okay, so ito lang yung gagamitin nating mga values. So be familiar lang dito. So para malaman mo lang yan is you will base the end conditions. So depende yung fixity factor dun sa end conditions. Okay? So what are the adjusted compressive strength, 'di ba? Balik tayo dito, 'di ba ang working formula lang natin should be this one to determine if your column is safe or not, 'di ba? So force over area shall be less than or equal to the adjusted compressive strength. So what are the adjusted compressive strength? Okay. So yung adjusted compressive strength or yung allowable unit stress in MPa of a cross-sectional area of a square or a rectangular simple solid columns is determined based on the column. If the column is short column, if the column is intermediate columns, or if the column is a long column. So nakadepende yung adjusted compressive strength ng ating column based on the slenderness ratio. This one is the slenderness ratio, LE over D. Okay, this one is the slenderness ratio for timber columns. Okay, so yung LE over D is the slenderness ratio for your timber columns. Okay, so paano ba natin malalaman, paano ba natin ma-determine if our column is a short, is intermediate, or a long column? So the compressive strength is adjusted based on that criteria. Okay, so first criteria is when LE over D is less than or equal to 11, your adjusted compressive strength is already the compressive strength given in the table. So for example, dito tayo sa allowable stress, okay, this one. So for example, meron kang gumamit ka ng Agoho 3. This one, Agoho 3. Okay, this one is your FC. Ito yung based on the table. FC mo is equals to 14.5 megapascal. So you are using 80% stress grade. So 80% yung quality or yung quality ng grade mo dun sa column mo. Okay? So when your column is short, 100% of this capacity will attain or is marireach marireach niya yung capacity na to kapag short column siya. So therefore, your FC prime is equals to your FC. Okay. So next question, next scenario is when your column is intermediate. Paano ba malalaman if your column is intermediate? When your LE over D is greater than 11 but less than K. Okay, yung K natin is yung limiting slenderness factor. Okay, what are the values of K or what is the value of K? Your value of K will depends if your timber beam is visually stress graded or machine stress graded. Okay, so katulad lang din yan doon sa timber beams, 'di ba? So sa timber beams natin, 'di ba, may lateral stability, naka-base din doon yung value of K. So ganun din dito. So yung value of K niya is depende sa kung visually stress graded or machine stress unit lumber. Okay, so kapag hindi sinabi sa problem, this one is the default value of K. Okay, so pag hindi binanggit sa problem, if that is visually stress graded or machine stress graded lumber, you will use this one, yung visually stress graded timber. Okay, so that is your value of K. So yung K natin kapag visually stress graded is equals to 0.671 square root of E over FC. Okay, so what is E? Yung E natin is the modulus of elasticity of your timber and FC is the full capacity of your compressive stress capacity parallel to the grain of your timber or this one. Ito yung pinag-uusapan natin. This one, 14.5 kapag parallel to the grain. Kapag yung arrangement mo is perpendicular to the grain, your FC na ilalagay mo dito should be 5.91 kung compression to the grain yung arrangement mo. Okay? So that is visually stress graded timber. So for machine stress timber, your value of K is equivalent to 0.792 square root of E over FC. Okay? Whereas, the same, yung E natin is the modulus of elasticity and FC is the full capacity or compressive stress of your timber. Okay? So yung adjusted formula, FC prime is equals to FC multiplied by quantity 1 minus 1/3 of the slenderness ratio over K raised to 4. Okay, so again, that is FC prime is equals to FC multiplied by the quantity 1 minus 1/3, okay, multiplied by LE over D over K raised to 4. Okay, so that is your capacity, adjusted compressive strength capacity of an intermediate columns. Okay, next scenario, if your column is a long column. Okay, paano naman kung yung column mo is long column? So when your LE over D or where your slenderness ratio is greater than K, okay, kung yung LE over D mo is greater than K, your formula is given by this one. Okay, this one is also, if not given, ito yung default value. Default value kapag hindi given. Okay, so kapag visually stressed graded timber, that the formula is 0.3 E LE over D squared. And if your timber is machine stress unit lumber, that is 0.418 times modulus of elasticity E divided by LE over D squared. Okay? So, this one, the notation lang naman. So, what is FC? That is your allowable compressive stress parallel to the grain. If your column is, or the orientation of your column is parallel to the grain. Okay? Your E is the modulus of elasticity of your timber. The L is the effective length, which is equals to KE over KE times L. So yung effective length, ito na siya, KE times L. Okay, yung D natin is the least dimension of the columns. So for example, you have 200 by 400 timber columns, you will choose 200 as your least dimension of the columns. Okay? So this formula is only for square or rectangular simple solid columns. So kapag ano kasi siya, kapag round column or bilog yung column mo, round section, you can use this formula. Pwede mong gamitin yung formula na to, and formula na to. However, you need to find the equivalent square column or square section. So for example, meron kang column na 125 mm. So get the area of that. So that is pi 125 square over 4. That is your area of the column divided by D squared. Okay, your D is equals to is equals to 100 10.77. So 100 10.77. So ang mangyayari kasi itong value of D mo, ito yung ilalagay mo. So ito yung equivalent area, the same area to your around cross section. Okay? So ito yung gagamitin mong value of D sa lahat ng formula na to. So LE over D, this one LE over D. Okay? So yan yung gagamitin mong value of D. So this is the equivalent square section. So do you have questions for this class? Wala
naman po.
Wala naman. So ano lang to, rekta lang natin tong gagawin. Okay, so let's try sample problem. Okay. So a timber column square cross section has a length of 3 meters, this one, and a dimension of 140 by 140. So we will use a nominal dimension. We will not use the dress dimension. Okay. Sabi dito, the support type is hinge at the ends so that your K is 1.0. So the relevant code on the compressive strength FC is given on the specification and also the table of timber with corresponding working stress for visually stress graded unseasoned apitong for 80% stress grade. So the problem is number one is your column short, intermediate, long column or not within the code. Okay, next problem is what is the allowable compressive stress? And lastly, what is the allowable actual load? Okay, so this one ang tinatanong is stress and this one ang tinatanong is load. Okay, sige, try natin. So before we start, wala pa tayong given kung ano yung capacity and ano yung modulus of elasticity E. So titingin tayo sa table. So sabi niya dito that is apitong. Sabi dito apitong yung wood, 80% stress grade. Okay, so apitong yung wood, ito. Sabi niya 80% stress grade, ito. Okay, so therefore the properties of the wood is the bending and tensile parallel to grain strength is 16.5. The modulus of elasticity is 7.31 times 1000 megapascal. Your compression parallel to the grain or FC is equals to 9.56 megapascal. Your compression perpendicular to the grain, that is 2.2 megapascal. And your shear parallel to the grain, that is 1.73 megapascal. Okay. So kunin natin lahat ng given. So i-write lang natin yung sinabi ko, that is this one. So 80% stress grade apitong, that is under a medium strength group na mga species. Okay, so your FB is 16.5. Your modulus of elasticity, that is 7.31 times 1,000. Bakit by 1 times 1,000? Dahil dito. Okay. Next natin is FC parallel to the grain, that is 9.56 megapascal. Your FC perpendicular to the grain, that is 2.2 megapascal. And your FB perpendicular parallel to the grain, that is 1.73 megapascal. So kompleto na yung properties of our apitong. Okay, so next natin, what is the value of your effective length, LE? Okay, sinabi niya dito, your support is hinge at the end so that your K is 1.0. So pwedeng hindi mo na to gawin, pwede mo na hindi i-recheck kasi binanggit niya yung value of K. However, kapag hindi binanggit yung value of K, you need to recheck the value of K based on the support type. Okay, ang sabi sa support type that are both ends are hinge or pin. Okay, so both ends are hinge. Saan ba dito yung both ends are hinge? So this one, ito yung hinge eh. Yung itsura ng hinge is ganyan. Okay, so both ends are hinge. So this one, yun. Okay, so that is your K is equals to 1.0. Okay, so next naman, ano ba to? Next naman is your effective length LE. Your effective length LE, that is your K multiplied by the total length of your column. So 1.0 multiplied by 3,000. So yan yung length ng column mo. That is 3,000 millimeters or 3 meters. So that is your effective length is 3,000 millimeters. Okay. So next question is the first question is find the LE over D and determine if your column is short, intermediate, or a long column or not within the code. So solve natin yung LE over D. This one, solve natin yung LE over D. So how are we going to solve for LE over D? Yung LE natin is na-solve na natin. That is 3,000 millimeters. Okay, then what is D? So take note that your D is the least dimension of 140 by 140. So since they are the same, you will choose 140 millimeters. So if not, kunwari 200 by 300, so you will choose the least dimension, which is 200. So ganun kapag magkaiba. So check nyo lang, 3,000 divided by 140. So ito is naka-mm. Itong isa is naka-mm din. So walang problema. Okay, therefore 3,000 divided by 140, you get your LE over D, which is 21.429. Okay, so going back to our formula for the compressive strength, adjusted compressive strength. So hindi na siya agad pasok siya sa short column kasi nga ang mga pasok lang sa short column is when your LE over D is less than 11. So since your value is 20 plus, okay? So hindi na siya pasok dito. So you don't need short columns formula anymore. So you will determine if pasok ba siya dito sa intermediate column or outside. So under na siya sa long column. Okay, so you need to find the value of your K. So hanapin natin yung value ng K. So the value of K, sabi niya dun sa problem, that is visually stress graded, or if not specified, this one is the default value. So whereas yung E natin is 7310 megapascal or 7.31 times 1,000. Okay, this one is from the table or for 80% stress grade for Apitong. Okay, your FC is 9.56 megapascal. So that is the compression parallel to the grain given in the table. Okay, so balik natin. That is this one, 9.56. And this one, 7.31 times 1,000. So that is your ENFC. Okay, so solve natin yung value of K. We get K is equals to 0.6271 square root of 7310 divided by 9.56. So this one is your value of K. The value of your K is 18.55. 18.55. Yan yung value ng K. So when compare yung yung L over D and the value of K, it is very obvious that your LE over D is greater than K. So 21.429 is greater than 18.5. Therefore, your column is a long column. Your LE over D is greater than K. Therefore, your column is a long column. Okay? So dito siya pumatak sa long column na to. Okay. So now, ang next problem is what is the allowable compressive stress? Ano ba yung allowable compressive stress ngayon? So the allowable compressive stress is given by this formula. So 0.3 times E over L E D or L E over D squared. Whereas this one is for visually stress graded timbers. Okay, so this one is your 0.3 multiplied by the modulus of elasticity E divided by your L over D squared. You get your 0.3 times 7310 divided by 21.43 squared. That is your L over D. This one. You get your 4.78 megapascal. So this one is the adjusted compressive strength. Okay, so kung mapapansin nyo class, lumiit yung compressive strength natin. So hindi niya na-reach yung full capacity. Ba't hindi ko mabox? Ayan. So tingnan nyo class, yung FC mo ngayon na gagamitin is 4.78 megapascal. Whereas, yung original, yung full capacity niya or the full capacity when the column is short, that is 9.56. So halos pumunta sa kalahati. So 9.56 divided by 2, you get 4.78. So almost kalahati yung nabawas. Or yung naging compressive strength niya is kalahati pala mismo. 4.78. So kalahati pala mismo. Okay? So nabawasan ng kalahati yung compressive stress mo dahil the allowable compressive stress mo dahil naging long column yung timber column. Okay? So next problem is what is the allowable actual load? Okay, so going back, paano nangyari to? Yung P or equals to A over FC. Okay? 'Di ba alam natin that your FC is equals to P over area that is less than or equal to FC prime. So ito lang to, that is your actual load or the demand load. So demand na lang to. That is your demand. Okay? Equate mo lang siya sa capacity. Siyempre dapat para makuha mo yung allowable actual load, i-limit mo lang din yung demand mo dun sa capacity. So you get P over A. Gagawin natin your P over A is equals to FC prime. Okay, so solving for P, you get, multiply mo all terms by A, you get P is equals to A F C prime, or the adjusted compressive strength. So therefore, your cross section is 140 by 140 multiplied by 4.78. That is your adjusted compressive stress. Okay, or adjusted allowable compressive stress. So therefore, you get 140 multiplied by 140 multiplied by 4.78. You get so typo error pala to, no? 140 by 140 by 4.78, so 93,688. So 9 pala dapat to. So this one should be 93,688 newtons. Bakit newtons? You get MPa, that is Newton per square millimeter squared. 140, that is in millimeters. Yung next na 140, that is millimeters. So millimeter squared times millimeter times millimeter. Okay, millimeter times millimeter, you get millimeter squared divided by millimeter squared, makakancel yan. Okay, therefore, your units is 93,688 newtons. So this one is your answer. So convert mo sa kilonewton, divide mo lang siya sa 1,000, you get 93.69 kilonewtons. Okay, so ayan lang yung ating pagde-design ng timber columns or yung timber columns with compressive stress parallel to the grain. So, summary lang ng ating pinag-aralan for today is the compressive strength is the working formula pala. The working formula is this one. Your actual compressive stress or your demand compressive stress parallel to the grain, which is P over A, shall always be less than or equal to the adjusted compressive strength design parallel to the grain. So this one is your working stress. So ito yung small capital F, that is ibig sabihin niya, that is your actual or the demand load. Okay, FC prime, capital F, that is your capacity. Okay, then in order to solve for the value of your FC prime, okay, yung adjusted compressive strength, you will need to determine if your column is short, if your column is intermediate, or if your column is a long column. Okay, so how to determine if your column is short, your intermediate, or long? You need to find your LE over D, or the standardness ratio for timber columns, and the value of K, or yung limiting standardness ratio. Okay, yung standardness ratio for the timber columns, you get your this one. So whereas yung L is the effective length, that is equivalent to the fixity factor multiplied by the total length. So iba-iba yung backlink factors niya. So ito, this one, this one, this one, this one, and this one, depending on the support type. Okay, then the value of D, that is the least dimension. Okay, that is the least dimension of the columns for a simple rectangle or a square beam. square column. Okay? So kapag short column, you get FC prime equals to FC. When intermediate column, this one, the value of FC prime is this one, 1 minus 1/3 LE over D, K raised to 4. Okay, and if the column is long, the formula is this one. Okay, so by default, you will always use visually stress graded timbers. Okay, so what if naman kapag round section, you need to find the equivalent square section of that square section or round section. So in order to do that, you need to evaluate or equate lang yung area of square equals to the area of circle. Okay, then get the dimension of your square. Okay, so that's it. So do you have questions, class, for this topic? Madali lang to kaya saglit lang tayo. Okay? Wala kayong questions?
Wala po.
Okay, sige. Yun lang. Next meeting natin is we will discuss the timber notching or yung paano ba dinudugtong yung timbers, yung pagna-notch na tawag nila. Okay, then also last natin is yung nails and bolted connections. Okay, so stop sharing and